Hey guys, I'm out today at a meeting, so I thought I would make a video of 4.7 to get you started. It's the last task of Module 4, and I thought it was really important that I do this because this task is real similar to what you need to know for the test. So I'm just going to do number 1 here to get you started, and then all the following problems after that need to be done in the same exact way. So we're given a function on 1 and the following problems, and we need to do all these different things for it. So the first thing that I would do when looking at these functions is identify what kind of function it is. So I can tell from this function here that it is a square root function, and down here this would be an exponential function. So I know from this that when I'm writing the equation that I need to keep those things in mind. So I always think when I'm trying to figure things out about a function from a graph that the best thing to do is to start off just with a basic table, which is what I'm going to do here for number 1. So I'm going to make a table. You should be copying this down. You could just do it somewhere over here in your module or over there. I'm going to use graph paper just because. But anyway, I know that I have x and y, or you could write x and f of x if you're more comfortable. And then I'm going to identify the points on the graph that can be of use to me. So the first one would be this. So -2, -2. And then this is also a nice one. So -1, -1. My 0 point isn't that great, so I'm just going to skip ahead to 2, 0. And then I'll go all the way to, let's see here, what would be the next one? The next one would be 7, 1. So 7, 1. And then I know that when I build this function that it's going to have some kind of a square root. So for this one, I start thinking kind of the problem from a domain type perspective. So to me it looks like the smallest x value for my domain is going to be -2. So that means that probably underneath the radical sign is going to be x plus 2, because I think what would make 0 in here, because 0 would be the smallest number that we could take a square root of and still have it be real. So -2 plus 2 would be 0, but we know that when we plug in -2, we get -2. So -2 plus 2 is 0, and then maybe if I take away another 2, it would certainly work for my first point, and then I would test some other ones. So I could test 2, 0, and 2 plus 2 is 4, and the square root of 4 is 2, and 2 minus 2 sure enough is 0. And then just test one more to be sure. We got 7, so 7 plus 2 is 9, the square root of 9 is 3, and 3 minus 2 is 1. So it looks like I've done the first thing I need to do on A, which is write the equation of the function. Next, I'm going to go domain. You can just write D, and I'm going to write it in the simplest way possible. So the smallest thing, as discussed before, that x can be is -2. So I'm going to go bracket -2. Brackets means that it's included, comma, and then I start thinking about the biggest thing it could be. Well, if I plug in anything bigger than -2, it's going to be a positive number and therefore real. So this can go all the way up to infinity. And remember, for infinity, we put a parenthesis because we never quite get to infinity. Next one will be, what do they want? The range. So the range is also going to be -2 to infinity. And then I have my intercepts. So this would be A, this would be B. You can show it on graph paper if you want to, or you can jot it into the margins of your module, whatever's easiest. But C, my intercepts, and then I start looking at where this graph is going to have an intercept with the x-axis. And for this problem, it looks like it's right here. So I have an intercept, an x-intercept of 2, 0. And then I have D, the location of the minima and the maxima. So the minimum is going to be -2 for x, and to be most specific, I would say it is -2 at x equals -2. So actually the minimum this way coming up is -2 here, where also x equals -2. And then the maximum, it continues to rise forever. So the maximum for this graph is infinity. E, let's see, intervals where it's increasing. I would say increasing always. Now when you get into future problems, you may have to write it's increasing from a certain number to a certain number, or decreasing, and then just kind of write it in interval notation. Let me scoot that over so everybody can see it. Okay, what else do we need? F, sketch the inverse of the function. So graph paper is really best for this. You could also just give me a rough sketch over here. But what I do want to see, because this is a super important skill to have for the test, is not just a plain sketch. You guys know that this reflects over the line x equals y. So it'd be pretty easy to just kind of take a guess at it. But what you need to do, at least somewhere, is to show your algebra for getting the exact inverse function. So our regular function was y equals the square root of x plus 2 minus 2. And I wrote y here because it's going to make things more easier going forward, because I know for an inverse, I need to switch x and y. So this is going to become x equals the square root of y plus 2 minus 2. And then I'm going to add 2. Then I'm going to square both sides. And I'm almost there. The last thing I need to do is subtract 2. And here is the inverse function. And I would say for today, getting this part of it is probably our most, I would say that and getting the equation is the most important part of this task. So now to do just a quick graph, I'm going to make a table. And again, for the inverse, the smallest value I can get without being an imaginary number is -2. So when I plug in -2, I get 0 squared minus 2 is -2. Then I plug in -1, plus 2 is 1, 1 squared is 1, and 1 minus 2 is -1. Then I have 0, not -0. 0 plus 2 is 2, 2 squared is 4, and 4 minus 2 is 2. Then I'll plug in 1, which is going to give me 7. And of course it does. You probably could have done that without plugging in the numbers, because we know that this table is going to be the exact opposite of this table. And if we go back and check, you can see how these numbers are now flipped. And then just for a quick sketch of the graph, I have -2, -2, -1, -1. I have 0, 2, and 1, 1, 2, 3, 4, 5, 6, 7. And I'm going up like this. And sure enough, this is the inverse of this. So please do the rest of the problems like this today and do an extra special good job for the sub today. And we'll go over everything again tomorrow, but I'd like it if you could have the task complete. And if you finish the task, go on to the RSG. Thank you.